remember
Recording.
yeah, and give me the permissions to share because you always forget.
Of course. Make co-host. Mussolini, do
Thank
you
you.
want to make the introduction today for the chapter 9?
So you should be able to see my screen, right?
No, okay, no problem.
Are you able to see the book? Can
Yes.
somebody confirm? Perfect.
Yes.
Okay, so today we are going to build upon what we talked in chapter 8, because chapter 8 was about reactive messaging. Oh, sorry, reactive programming, which is basically a way how to basically write asynchronous API in Quarkus. Today we are going to extend on top of that to the basically main goal where we were aiming with it, to Quarkus messaging. Basically, Quarkus messaging is a way how you can integrate with any asynchronous communication systems like Kafka, RabbitMQ in Quarkus, or JMS, or something similar like this, IMQP protocols, etc. We purposely named it Quarkus messaging, or it's now named Quarkus messaging because originally it was, and it still is, the microprofile specification upon which the whole Quarkus integration is based on is called microprofile reactive messaging. So you see the natural pathway from reactive programming to reactive messaging. It's kind of a prerequisite. So this is why it's coming here only, even when it's like the concepts are like throughout the book, and you will see that we kind of implemented parts here and after. Just I really want to like put you into the context. So basically, what is the idea of this like reactive messaging? But I will be saying Quarkus messaging, which is purposely just so that you understand that you are not required to write reactive code to do messaging with Kafka or something similar. It's just the name of the specification is reactive messaging. Also, the implementation is small reactive messaging. So we purposely just named it Quarkus messaging from now on, so people don't confuse it that if they want to give it a try or integrate with systems like Kafka, they need to write reactive code. You don't have to. So, okay, so what basically that whole idea of this messaging is, or this asynchronous messaging is they basically in the last chapter we talk about reactive programming and how it is basically better at utilizing your existing resources, so you can do more with the same amount of resources. Basically, messaging, or this reactive messaging, is taking this concept and basically doing a realization that nowadays we are like I would say like almost always going to write systems that are split into different applications that need to communicate with each other. So why not take the same concepts that we have in reactive programming and just like distribute them throughout the network? And this is exactly what basically this reactive messaging or Quarkus messaging in the background is about. Because here we just see like the image. Today I will stick more to the book because we basically need to like there is so much code that we are actually implementing. This is one of the longest chapters. So and there is a lot of configuration and a lot of just like POJOs for transports, etc. So I really opted to now today stick with the book because I would just spend the time typing POJOs, which is not so interesting. So today, we are going to actually add the last service that we have in the book, the billing service, which is fully reactive service integrated through Quarkus messaging to two channels or two providers, Kafka to communicate with rental and RabbitMQ for communication with reservation. However, before we will get there, and I think that I will even not do like all of these integrations because this is just typing of the code, which you can read in the book. But I want you to take from this basically presentation what Quarkus messaging is about and the ideas why you should consider adding it to your applications. So as I said, it's taking the same reactive concepts that we had last time to distributed systems. Actually, this idea was created or defined originally in 2014 in this so-called reactive manifesto. It's written somewhere there, somewhere here, which you can read actually this URL, which is basically a document which describes so-called reactive systems. Reactive system is nothing fancy. It's just a system that has these 4 properties: responsiveness, resiliency, elasticity, and it's based on asynchronous message passing. Basically, the whole idea is that nowadays, when we are like in 2025, our applications need to be responsive, because you know that people don't really are, like, basically people lost the ability to wait for something to load. So in Google, for instance, I know that they have the SLA for 200 milliseconds, because you know what people will do when they basically don't get the response right away. They will just start hitting F5, and you basically have distributed denial of service on your end because you are just slow. So responsiveness is one of the most important property of the reactive system. Based on that, we then have resiliency, which is basically the ability of your system to survive failures. Basically, if there is something wrong, there shouldn't be like a lost order or a lost message or any kind of failure. And of course, it shouldn't really be propagated to the user if we can handle it throughout the system. The basically elasticity, the next property, is just the basically extension of this. We should be able to scale the number of instances that our service provides, or we are providing of our service, dynamically based on demand. So if we have, like Black Friday or something like this, we should be dynamically able to add more instances very quickly to scale up to basically answer all the demand. And when it's no Black Friday, then we should be able to scale back down to the same amount of instances. Basically, you can already see that the resiliency is just logical extension of scaling to 0. You should be able to still handle that. And basically, that's more or less it. And all of these 3 properties are conditioned by asynchronous message passing, or this message driven. So we basically define that every communication between individual parts of our application, and it doesn't matter if it's the same JVM or it's multiple JVMs, needs to be based on message passing, on probably asynchronous message passing. So everything is exchanged as messages. Also errors, everything. If you have this, then you can basically say that you have a reactive system. This is everything defined in the reactive manifesto. So I would say that these 4 properties eventually become relevant for any system that it's going to scale eventually. And many of these systems, at least in my experience, are finding these requirements only too late when the system is already deployed somewhere, and adding them at that point is extremely hard. So it's good to think about this, and it's also in the manifesto from the beginning. So you are designing the system with these properties in mind. Well, and then we have microprofile reactive messaging. Microprofile reactive messaging, I'm not sure if we talk about microprofile yet. So I will just really quickly say it's a bunch of, I think, like 12 specifications, which was created as an alternative to back then Java EE in 2016, if I remember correctly, because Java EE was moving slow. But since then, we basically got to Jakarta and it's moving again. But microprofile took its own life, and it added a bunch of specification like config that we already had, or health, or I like from my head metrics, etc. Basically, specifications. Basically the same specification as you nowadays have in Jakarta, just really focused on cloud native application development. So everything like health is relevant in Kubernetes, observability, for instance, telemetry, and this kind of stuff. That's in microprofile specifications. And one of these specification is microprofile reactive messaging. Reactive messaging is actually not part of the microprofile like core platform, which you can like find with some bomb somewhere on Central. microprofile has a concept of core specifications, which are mandatory, and then it has like 5 or 6 standalone specifications, which are on the side, but they are like full specifications with everything that the specification should have. Just if you want to be compatible with microprofile, you don't have to implement them. So when you will see like some implementation of microprofile, now you will see my awesome script, which is called kill chats. So it will shut up. These standalone specifications are optional, so you need to always check, even if your implementation or your framework is saying it's microprofile compatible, it doesn't mean that it will have reactive messaging. In Quarkus, we are implementing everything in microprofile except for microprofile metrics, because we have micrometer, which we will have on the next session, or open telemetry. Okay, so microprofile reactive messaging, as I said, specification, which is nothing else, just taking the reactive streams API or reactive streams concepts which we had in chapter 8 and extending them to be applicable in the CDI beans or in methods in CDI beans. So basically, you will get the same execution model, just it's not put together through Java API manually like we did last time, but the framework will do it for you through the CDI, through dependency injection. We have here a slight turn away in the book, which is just telling you that when you have synchronous or asynchronous distributed systems, like you know that when you have synchronous communication, all services in your system needs to be running all the time, because if something is not running, that you will just get the error. And it's just a question if you are able to handle the error somewhere in the chain where it's propagated. But very often, and even when I am using just like normal internet, that error will get back to the user. And you know, like you don't want your grandma to read, you know, like stack trace from your Java application, because it doesn't really make sense. So in asynchronous message passing, we are sending everything as a message to some form of virtual address. So we don't even like directly communicate with services. And probably I should have mentioned that we actually covered all of the like most popular synchronous protocols in chapter 4, which was REST or HTTP, gRPC, and GraphQL. These are like all suffering from the same issue. So in asynchronous message passing, I am sending messages to a virtual address. So I have no idea if there is some service running, or if there are like if there is one service running, or if there is like 50 services running, and I don't really care, because I am sending a message to a provider like Kafka, for instance, in asynchronous way. So basically, I will send it, and I can just optionally wait for again asynchronous acknowledgement, which we will get into in a minute. So if something fails in this asynchronous message passing, like let's say that I'm sending 4 requests, and after first 2, my service B goes down, then the channel usually is able to buffer the messages until there is somebody that is able to consume them. So if in the step 2 or time 2, my service B will come back again, it can start processing the messages. And let's say that after it will produce or process all the messages, service C will go down after it consumes only message 3. Again, message 4 is just buffered in different channel. And this is that power that if you have like a solid platform like Kafka RabbitMQ, which is usually managed by your cloud provider, then you can rely on it that it will basically handle this kind of issues for you, which you don't have in REST. In REST, in like synchronous communication, there are strategies how to mitigate failures, and we will actually talk about them in actually chapter 10, where we will show fault tolerance strategies, which are just able to do something like retries or timeouts or fallbacks and this kind of stuff. So you see, it's more mitigation of the problem. It's not really a solution to the problem. Because like, of course, Kafka can also fail. Nothing is 100%, but it's still more reliable or resilient, if I may, than something like retries. Okay, So as I said, basically exactly the same reactive streams API concepts that we had before, just now we are pushing them through CDI methods. These CDI methods can be, but doesn't have to be inside the same CDI bean. So as long as you have a communication channel defined between two methods, they can be in totally different parts of your application. It doesn't really matter. So here you see we are doing exactly the same thing. So like some like there is a producer that is producing, I think, blue squares. Then we have processor that is changing it to red. Then we have another processor circles. Then we have a processor filter. So it's like deciding to not produce some of the items. And then we have consumer at the end. But like exactly the same concept as we had before. The specification out of the box defines the bean in which this CDI method is able to be like processed by the framework or by the implementation needs to be application scoped or dependent. I actually think that in Quarkus we are able to do like more, but I'm not sure. So I will like park it. Okay, so how do we define this kind of communication? Is like the whole specification is just two annotations, outgoing and incoming. They both take a single string parameter, which is the name of the so-called reactive messaging channel. Reactive messaging channel, you can imagine like that virtual address to which we are sending or consuming from, like sending messages or consuming messages from. And then basically, if you want to define something like reactive streams producer or publisher, then you will just use outgoing to some channel. Then you are just producing items. If you want a consumer, incoming from some channel. And if you want a processor, then it has incoming and outgoing. Nothing so complicated. This is extremely easy to like imagine or like put together. However, the underlying like all of that channels putting together is extremely complex, but that's not your problem. This is what Quarkus should handle for you. So yeah, basically how to define these methods, I believe, yeah, we have here an example. I can actually open that because we have this in the book, and this is 932. So here I have in the book in the chapter 9. Oh, what did I do? Okay, I copy pasted somehow. I'm good. So in chapter 9, I can go to 932 and open this in IDEA. And I don't have IDEA running. That is unfortunate. Unfortunately, I forgot that I stopped the only IDEA that I was running, so I need to open a different IDEA if I want to use my script, because otherwise we will be running the IDEA in this terminal, which I want to use for different stuff. So now in this 932, we oh, sorry, one more. Here. I don't remember what I typed in the book. Okay, it doesn't matter. I can find out what I did. So we have like only like really basic application with the example of that processing. So here you can see that I have one single producer with the outgoing annotation, which is producing to a channel named Tix, which is actually producing a multi, because in reactive messaging, they are fully integrated with the reactive streams API or with the JDK9 flow subclasses or like flow dot something classes. So actually you can use directly publisher or subscriber interfaces in these methods, and multi is actually a publisher. So I can directly use multi here because it's a publisher. So here I am using just, I'm not sure if I showed you this last time, but multi has this like create from, create by, etc. I was definitely showing that. And one of them is ticks, which I can basically say like every second or like every other duration, just like send an item. And I will basically limit it to 5 items. That's everything what I will do. So my publisher will publish 5 longs, and then it will stop. It will send a completion event. Then I am consuming that ticks channel with incoming ticks in this method processor, which is taking multi as an argument. doing some mapping, it doesn't matter, to some instant, and it's again producing multi of string. So this is how easy it is to define if you know that reactive programming or like small RAM mutiny to that extent APIs. You see that basically how this multi is basically subscribed, or how it is like processed in the background, everything is hidden from you. All you will do is basically define your reactive processing in your method, and whatever you will return, Quarkus handles accordingly. So I am basically saying that this multi-string should be produced to another channel called times, which I'm consuming here. And this is my consumer already, which is just printing the payload to the console. So if I run this, I should get 5 timestamps, and then it should finish. And here we go. So nothing so fancy, but you see that there is actually the first one is here. So it starts like faster than we are printing like the Quarkus logo. So like you need to believe me. Okay. So basically that's it. This is the whole point of reactive messaging. You are defining this incoming outgoing, and this can be wired through different CDI beans. Just remember that at path, like the REST resource in Quarkus is automatically denoted as CDI bean. In any other normal Pojo, you need that bin defining annotation. So either application scope, request scope, session scope, or like, I don't remember. Like I'm using only, or singleton, for instance. So basically, otherwise it will not work because it needs to be a CDI bin. But more or less everything that we will be doing like from now on needs to be in CDI bins, because like all the interceptors, everything needs to be basically annotated from CDI 5, I believe, which changed the default because it used to actually be like every Pojo or every class was considered a CDI bin by default, and you could change it to only with annotation. But in latest CDI major, they changed this, and you need to by default have annotation, and you can optionally change it back to everything. Okay, back to the book. So yeah, that would be more or less for the reactive messaging in single application. However, like, yeah, it can be useful. Definitely, it is useful when you are moving to distributed communication, but for now, we are just in one application. Very shortly, I want to stop at messaging acknowledgements. I hope that I'm saying it correctly, which is basically a way how to either confirm or negatively confirm. So you have X acknowledgements and negative acknowledgements, next, the asynchronous processing. And this is again asynchronous. So by default, when you are sending messages through your chain, every message which is sent between 2 points, so one producer, one consumer, even if that consumer is processor and it's again publishing item somewhere else, needs to be acknowledged back. And how you are like, if you are even caring about the acknowledgement is up to you, of course. But by default, the specification, the reactive messaging defines in which cases how the acknowledgements are being handled. We are not going to go into details. This is usually defined by the signature of the method that you are choosing. And you have 2 types of acknowledgements. It's either implicit or explicit. Uh, if you have explicit, then you need to basically consume your message wrapped in a message class, which is provided by the specification, which then have egg or neck method, which you can manually call based on your logic. However, more often you will find out that people are using implicit acknowledgements, which we are actually also using in that ticks and times example. You can override the implicit acknowledgement with this at acknowledgement annotation, but if you don't use it or you don't consume the message wrapper, then you are using something which is defined as default. So in this acknowledgement, we actually have one parameter which we can set, this strategy, which has these 4 values. So it's either manual, which basically means you need to consume message and call manually egg or neck, pre-processing, send the egg before we will enter the method. Post-processing, send the egg after we will finish the method, or send a NUC with the exception if there was exception. And then we have also to do nothing, which I personally never saw so far, but I was told that this can happen if you are handling acknowledgements in some different way. But I still am up to see like how this is actually going to be used. So then if you have this annotation, you see here the example how to like put it on if you want to do manual acknowledgements. So I will set the strategy to manual, and then I am wrapping my payload in this message class, which has a method get payload, so you can still get to your message. And if you decide that it's okay, you will call egg, and if you are deciding that it's not okay, you will just say call neck. That annotation, as I said, is not mandatory. So in my example before, with that default, like with that channels that we had here, actually the X are sent between both channels. However, where is it? For that signature, the default is post-processing. So it will send egg if there is no extension, no exception, or neck if there is exception. So up to you if you want to use it. It's just good to know that this option exists if you want to somehow control the flow of the messages. However, you are not required to use it manually. Basically, something which I forgot to say, if you have a multiple CDI methods, which, or as I already have in my examples, if you are sending messages between individual hops in the chain, the X are always built, sorry, okay. The X are built always in the opposite direction as of which the messages are being sent. And basically, so the first publisher who is publishing the message will be the last to receive the acknowledgement back. So they are like going in hops and then in hops back. Of course, if there is a negative acknowledgement, usually you are not continuing the chain anymore and you are just like propagating next or X back. Okay. Okay, so the next part that we need to take a look at is integrating imperative and reactive code, or imperative code with reactive messaging, because usually you don't expose, like your Kafka topic or RabbitMQQ. You usually need to have some front end which the user will access, usually through HTTP. So you need to somehow get from that imperative side to the reactive channel. And how this is being done is through these two things. Add channel annotation, which again takes a single string, which is again the same channel, the same virtual address as we have in incoming and outgoing. And this emitter class, which is parameterized by the type of your message, which is just having like this one nice method send, which is basically just sending whatever you will put there as a message to a reactive channel. So this is how you will bridge from imperative to reactive. However, there is also a way, and I should probably say that this send returns a completable stage, completion stage, which you can actually wait for if you want to. And this completion stage will be completed when you will receive the acknowledgement. If you will receive a negative acknowledgement, this completion stage is completed exceptionally, with the exception provided in the neck. Okay, this would be from imperative to reactive. However, there is one more use of this at channel annotation, and that's actually on injection of multi somewhere, which is basically a way for you to consume reactive channel into a publisher, which is extremely useful in this single scenario when you want to have server send events. Server send events is HTTP concept where basically client through HTTP subscribes to a server to be asynchronously notified with some items as they are coming. Extremely useful for like, for instance, like even AI, for instance, when you are like sending the individual words in chunks, so you are streaming something. Actually, we have this as an example in 934, so we can go check 934. again, idea. So again, greeting resource. I should have renamed the greeting resource, I suppose. So here you see that I am using that channel annotation coming from microprofile reactive messaging to consume it to multi. But this ticks is actually a channel which is being produced by my producer, which is just, again, doing ticks. It doesn't really matter what the multi is doing every second. So if I now call this ticks consume, and let me just copy the command from the book, because like, why should I be typing it? I need to run it. Sorry. So in HTTP EE, we can basically define that I want to consume server send events with this minus minus stream, but in the book you have also how to do it with curl. So you see that I actually ask for text / event stream. This is the server send events, and now I am subscribed to that multi, which is producing every second a tick, which is now coming back to my application to my basically client through HTTP. So this is that other use case for which we are using, and we stop dev mode, for we are using the channel annotation. Yeah, that would be more or less it, because you have both sides from imperative to reactive. Okay, that would be for now everything that we need to actually start doing some of the reactive messaging programming, at least in reservation. But like, I will really just go through this fast because it's more or less like creating some like pojos and like injections. However, I'm not sure if I really want to get into details and showing you how this is put together, because really this is just a lot of coding and a lot of configuration, which we don't really need to dive into because you have it written in the book. My intention is more here to explain the concept, and then you can like read how it's like actually implemented in the book. So I'm like thinking that I don't really have here anything that I want to go that much into. Here is something that I want to show you. So we are, of course, like billing service is going to produce like consume and handle invoices for the reservations and for the rentals. So in the billing from the reservation to the billing service, we are basically saying the first invoice when somebody makes a reservation. That's why we have here everywhere an invoice completion stage, which is coming from our invoice emitter, which was exactly the same emitter that we had somewhere else. I just need to see here it is. So it's emitter invoice emitter, and it's just producing the POJO, which we defined here, which is nothing fancy. As I told you, this will like this send method produces a competition stage. So here we have an example how you can actually wait for that competition stage to finish, because we actually don't really need to wait for the whole invoice to be processed, because remember, it's like one hop in the channel. So if the acknowledgement from the billing just comes when it receives the invoice request from the reservation, that's enough for us at the reservation, because we know that the billing service knows about this invoice, and then it's a responsibility of the billing service to handle that it's actually being paid. So from reservation, we basically just need to wait for the acknowledgement from the sending of the invoice, and that completion stage can be wait as this. So like I can say like when complete, then if it's throwable, then handle somehow the failure. Here I am just logging the exception, it doesn't matter. However, this is not so nice to use, like the whole competition stage compatible future APIs. So in small I reactive messaging, which is integrated in Quarkus messaging, you actually have this mutiny emitter, which is otherwise exactly the same as like reactive messaging emitter. Just when you call send, it will basically not return competition stage, it will return a uni of the acknowledgement. So we can nicely, here it is. So if my send will return a uni of void, which is either producing item if you have acknowledgement, or it is producing a failure if you have negative acknowledgement. Why is that? Because then we can very nicely integrate it with other reactive messaging pipelines because they are both always in Quarkus based on small mutiny. So here, when I am sending my invoice emitter sent new invoice to my channel somewhere invoices, which is then going to be mapped to actual reactive channel to billing service. But for now, it's in the reservation itself. We are also consuming that channel inside our application. Then you see that the invoice unit can be nicely chained into either calling the rental. At the end, we are just replacing it with persisted reservation. Or if we are not calling rental, then we can just directly replace it with the persisted reservation. So in that sense, I know that I'm going to return from my pipeline here only after I will receive an acknowledgement for the invoice. This is how we are chaining the actual invocation. So hopefully this is not so hard. You can read the code in detail later. Basically, here we can also define this on failure, for instance, callback. So it's still going to log our error or process our error. However, then it's going to still replace whatever the error is with the persisted reservation and going to continue. So this is how you will write the reactive code, and it's depending on you. Now we are getting to probably the most complex stuff. If this is hard to read or hard to comprehend, so like it's your decision. But I hope that we talked about this last time in Quarkus. And actually, I have it open right here, right? In Quarkus, you can fully mix and match imperative and reactive programming as you want, even in the same class. So here I am using reactive. This is still reactive, but this is imperative. And this is again reactive. So even in the same class, I can choose which parts of the code are executed asynchronously or in reactive manner, and which part needs to stay imperative, or what is easier for me to do in particular case. In different frameworks, you usually need to make the decision when you are creating the application. So this is extremely big benefit. Okay, so that would be more or less like very shortly how this is done. Here in this section, which I forgot, 9 for something, we just created the actually when you are calling reservation, it will produce asynchronously a message to a channel invoices, and we also define the consumer for invoices somewhere. Yeah, just as application scope class, like step billing service, which is just consuming everything from invoices and just printing the result. So now if you called it, it will actually produce the message, but the message is consumed in the same application. We have it actually in the diagram here. We will get into a second, like how this is being handled, but like for now, this is what we have. Like, so we are producing reactive messages, but only in the single application. What we want to now do is to produce them into, in this case, RabbitMQ. And this is where we run into last concept from the reactive messaging specification, which is called connectors. Connectors are nothing fancy. They are just concepts which you will plug at the edge of your application or like as a connection point of your application that is specifying how your reactive pipeline or your messaging pipeline should propagate messages outside from your application boundary or consume messages back to your application boundary. So basically, we have exactly the same application processing as before, like a bunch of CDI methods with these incoming, outgoing annotations. Just at the end, we will do outgoing to some channel, which is defined in the configuration properties to use connector, like for instance, Kafka or RabbitMQ. And basically, Quarkus messaging extension will handle it. So the message produced to that channel is actually pushed to Kafka, IMQP, Camo, MQTT, etc. And on the other side, we can exactly in the same way, just we will use incoming annotation, consume messages back to our application. So this is how you will define that reactive pipelines throughout the applications with the concept of connectors. That connectors are, as I said, usually defined purely by configuration properties, because implementing something like connector is not like super easy, but it's also not like super hard. But typically you don't really need to do it yourself, because like every major popular messaging platform already has its own extension. So if there will be something new, we'll probably implement the connector again in Quarkus. So typically you just need to find the correct extension, which is really just messaging Kafka or messaging RabbitMQ, which is required for your particular case. But they are all configured in the exactly same way, which is extremely easy to remember because they are coming actually from microprofile specification. So you have this mp.messaging dot either incoming or outgoing. Then you have the channel name, which is that string which you are writing into incoming, outgoing, and in channel annotation. And then you have like whatever value you want to configure. You can also define like some properties based on the connector. If you have like the same attribute configured for the connector and for like either incoming or outgoing, this incoming, outgoing will take precedence. They are like more granular. But something which you need to remember that this is also the exactly like the issue is that you need to always define the both directions. So either like consuming incoming and producing outgoing, even if you are going for the same provider. So if you are pushing to a Kafka topic and consuming from the from the same Kafka topic in your application, that you need to have the same attribute defined for incoming and outgoing. This is by design in the specification. Yeah, but this is more or less it. Then all you need to do, so we are starting with Kafka in the book. It doesn't matter. All you need to do is add your extension with the connector, which we are adding with this Quarkus messaging Kafka. And actually in Quarkus, if you have only one connector on a class path, so one connector extension, then out of the box, every channel which is not consumed inside your application is automatically configured to be pushing or consuming from basically that connector. So in my case, if I just define this messaging Kafka and I will not consume, and I don't think that in rental we have nothing yet. So let's say that if I would just define it in reservation with that invoices channel, and I would remove that incoming invoices consumer, then I would actually be pushing to invoices topic in some Kafka, which we will soon see that we have a dev service for. Okay, so yeah, again, just a bunch of POJOs and communication stuff. So we don't really need to care about it. Here we are getting into interesting stuff. So we have our emitter of invoice unjust messages, which is one of the messages which we are sending from rental. It doesn't really matter. Which is just like sending either if you will return the car sooner than you originally planned, then you will be refunded for the rest of the days, or if you will prolong the rental, then you need to pay whatever you prolong. Nothing fancy. And actually, I should have mentioned that billing service is also just like waiting something between 1 to 5 seconds, and we imagine that the invoice is paid. So we are not like focusing on like actual logic. Okay, so let me actually, open this. So that would be 961. 961. 961. Perfect. So let's go to rental service where we actually have that Kafka connector, I hope that I am incorrect. So we should have this Quarkus messaging Kafka. So one thing that I want to start with, so we have our invoice unjust messages, and let me just quickly see if we are consuming this actually somewhere. We are not. Perfect. So if I run this in dev mode, as I already kind of told you, all of these like messaging connectors come with a very nice dev service. So if I don't have connection URL for Kafka, then of course, oh shit. Yeah, this is something that I need to fix because Red Panda was renamed to something else. Oh, what was it renamed to? Red Panda data. Okay, this is actually an issue that is expected, and I just didn't have time, come on, to fix it yet. Quarkus messaging stuff. Okay, sorry. I now at least you will see that even like a core Quarkus engineer needs to always sometimes go into Kafka dev service, into this like dev services. Kafka. Because I don't remember what the actual configuration is to change the image on top of my head. And it will be something like this. Kafka, come on, Kafka. There is no Kafka? Huh. Okay. Quarkus, Kafka, services. Services for Kafka, change the image, configuring the image. So this is what I'm looking for. Quarkus Kafka Dev Services Provider. I don't remember these properties on top of my head. So here I just need to say docker io red panda data red panda, I think. Because this is actually not our mistake, but like 2 months after the book was released, Red Panda decided to rename their organization from Vectorize to Red Panda Data. So they broke Quarkus 3.15.1 because this is like actually hard-coded default value for that configuration. And what? Okay. That's probably not the one that I want. I want this one. Sorry, not provider, because actually this is defined in the book. Docker red panda data panda data panda. The provider is actually something different because Kafka in particular has the option to either use Red Panda, which is very lightweight version of Kafka. Yeah, it works. Now I am actually, you see how I'm pulling the image because I don't have it locally in my registry. So at least I can talk throughout it. And it's already running. Then you have Kafka Native, which is something which was done by one of the Quarkus messaging engineers, Ozan. That is basically very small, lightweight Kafka, which is just like a Quarkus application that is imitating Kafka. Or you have options to use Streamzy, which is Red Hat or now IBM product, like fully fledged Kafka cloud deployment. And we are actually using Streamzy by the end of the book when we are deploying to OpenShift. Okay, so I know that you don't really need this. Mongo client is still from like previous chapter 7, I hope. But you see that we got Kafka because I didn't configure connection to Kafka. And you see that somewhere here, no, somewhere here, this is what I want to show you. Dev services for Kafka starters. Other applications in dev mode will find this broker automatically. For production mode, you need to actually specify some property. It doesn't matter. But, oh, no. This is what I wanted to show you. So as long if you are on the same machine and you have two dev modes who both want a Kafka dev service, they will actually find the same Kafka container, the same Kafka instance automatically. So if I will then later run billing service on the same machine, it will not start its own Kafka. It will connect to Kafka started by rental service. And this is extremely powerful feature because you will see by the end how much of this like dev services magic we are using when we have the full application. So yeah, that's more or less it. I hope that I will see configuring channel invoices adjust to be managed by small Kafka connector, and it generated a serializer for JSON messages for me for my Pojo class. This is what I just wanted to show you, that out of the box, if I would now to connect to that Kafka container, small reactive messaging sees that I have a channel that is going to be produced to Kafka. So it will go ahead and proactively, it will create the topic in Kafka for me. So I don't need to do it manually, at least for this dev service. And that's it. Now, if I would send the messages, it would actually start sending messages to Kafka, but nobody is consuming them, so it doesn't really matter. But if you actually, this is everything written here, if you would actually define a consumer, where is it? Somewhere in your application. So like if I just do at incoming invoices adjust, okay. And that would be public, whatever, wait, volume, invoice adjust, invoice adjust, see out invoice adjust. Then if I restart my application, actually, I'm surprised. I thought that this shouldn't happen because I thought that if it's inside the same application, it will not send to Kafka. So I'm actually surprised, pleasantly surprised, because like if I remember correctly, if you have the that's probably because it's a channel. If you have both the consumer and the producer and the consumer inside the same application, the reactive messaging should backtrack back to so-called in-memory channel, which is that same thing that we use so far because we didn't have a connector. So you are not actually making the round trip to Kafka and back. So you are just staying inside the same application. However, for some reason, it is actually configuring now channel still to be in Kafka. Like it's, I thought that I shouldn't see this message now here. But maybe it's because I'm just doing live reload, and if I would do Quarkus dev with clean, now it needs to stop Kafka and Mongo. Come on, be faster, my computer, please. QDC is just Quarkus dev minus minus clean, so it will also clean the previous state of the project. No, it's still connecting to the invoice adjust. So I suppose that now if I have the only the messaging Kafka connector, then it will automatically push something to Kafka. But like it's surprising to me because I think that it shouldn't have. Or maybe it's just saying that it's like configuring the channel. Or maybe I made a typo, but like I think that this is written in the book, so it's just like surprising to me. But you will find out when you will be using it if it's going to Kafka or not. Okay, that would be more or less it. The probably last thing that I want to show today, because we are running out of time, is how you can test it. And this is not something that I'm going to implement. Kafka actually comes with its own testing extension called Test Kafka Companion, which you can then use in your Quarkus test like this. You will inject Kafka Companion, which is provided by the dependency, and then whatever you will do, you just need to call the code which will produce the message to Kafka. Then you can basically just do in Kafka Companion consume strings from topics, your topic, how many, and yeah, basically blocking API to wait until there is a message consumed from the topic. Very easy, very extremely nice to use. Why we are showing this inside the book is because then when we will move to RabbitMQ, which is actually exactly the same thing, just different POJOs sending here and after, but we will see exactly the same thing. Invoices RabbitMQ to be managed by small I, RabbitMQ, etc. Small I is here because the actual name of the connectors is still small I Kafka, small I RabbitMQ, because the implementation is called small I reactive messaging. So like they are coming from that. Here we are, for instance, overriding the queue name to actually push to Kafka. So probably this works only with Kafka and it doesn't work with RabbitMQ then, because like I'm almost sure that we did this exactly for that reason which I was describing before. So that Kafka Companion, as you saw, was very nice. For RabbitMQ, we don't have anything like that. So if we want to write the test for RabbitMQ, we actually need to do it manually with reactive messaging. And it's nothing fancy. We are just basically, you remember that Quarkus test is still a CDI bin. This is what the power that we have. So we can like directly use incoming our channel inside the test and just like manually like track the actual messages which are produced to the channel on our end. Nothing fancy, like pretty straightforward. And basically we will end the whole chapter with actually creating the billing service, which is more or less up to you to develop, because most of the stuff is what we saw so far inside the book. But then we will end with this very nice complex thingy. So we have small RabbitMQ connector in reservation and in the billing for the actual invoices. So we have RabbitMQ queue invoices, and between rental we are using small Kafka connector for either invoice adjustments from rental to billing, or invoice confirmations from billing to rental. And basically for the next 10 pages, you are just going to implement this thing. So we are not going to do this today. I hope that basically I gave you the idea what Quarkus messaging is about, and here I would park it, because like then it's up for your own studies. Any questions? If not, then we are done.
I think the basics are cleared now. It's all about home studies.
Yeah, like I cannot possibly like implement all of this in 1 hour.
Yes,
like,
yes. That's the main thing.
But in the book, it's like pretty much in the detail, and like even the optional parts, everything is in the individual directory inside the book code. So even if you are stuck, everything is on GitHub. And I need to push very big force push tomorrow to fix that vectorized to Red Panda, which is going to be fun. Okay, I think that we are done then, Matheus.
Yeah, we don't have questions, then we are done. Thanks a lot, Gustavo, João Nascimento, Mussolini, and again, Martin Stefank for this great section. And see you in the next section, the chapter 10, talking about
actually microprofile. We are moving to the last part of the book, which is Quarkus Cloud and Beyond. So we are actually going to do cloud native application patterns, and we are going to dive to the microprofile specifications that we didn't touch on yet.
Great. I'm seeing here observability stuff too.
Yeah, that there will be like a bunch of different stuff. So like really cloud native application development.
Great. Thanks a lot again, and see you later. Bye-bye.
Thank you, guys. Bye-bye.